These cables are actually quite smart because when you look inside, they have little notches here, right? And it's not a uniform symmetric pattern. It's irregular. And correspondingly on this side, you have the grooves with the same pattern here. So there's only one direction you put it in, it will fit here. But it's useful to try to find, there's usually a big rectangle one, and then there'll be a big rectangle one here. So if you put it close by, did you hear that click?
We can hear
See?
the sound.
Yeah. And then, oops. Sorry. And then you can twist it in, okay? But all of these will behave in a similar way. There's just one pattern that fits the best.
All right. The next thing we're going to do is we're going to put our source. The source. Which is the sledgehammer for us.
Source.
Yeah.
Source.
Yes.
Yeah.
The total length of the array is 0.5 meter spacing for 24 geophones. That's about 11.5 meters, right? So the rule of thumb is you don't want to be too close and you don't want to be too far from the array. If you're too close, there will not be opportunity for the surface waves to build. If you're too far, your source has attenuated before it even reached the first geophone. A general rule of thumb is 10 to 20% of your array length. 10 to 20%. So if I have 11.5 meters, an extra meter, a meter and a half should be plenty. So here we are at 11.5, so we can put the source at 13, which is here. This is 13. So this is the source. Now for MASW, you guys have questions? Sorry. Yeah. And I'll cover that later also, we're going to talk about that. For MASW, because we like to go for lower frequencies, because that's how we go deep, it's better to use a plastic plate to hit on. As opposed to a P-wave survey, where because we want this steep first arrival, that's how we see the first arrival of the P wave, and we want this to be as steep as possible, as high frequency as possible, we hit many times a metal plate. So that's one of the difference between the techniques. We will still hit a plastic plate here and we'll still get a P wave, we'll see it, but when you start looking at the exact arrival, that's where you may want to have as high of a frequency content as possible. But I think for today we're good. So this is 13 meters here. We don't want to be hitting on top of the plate. We're not using that anymore, so given that I know that I need to put it there, I can move that around and put my plate there. Alright? Because you don't want to hit on top of the plate. And then this is our source, which is a 10 kilogram mass. And we're going to use it to hit on the plate. To hit on the plate, so we will see later on when we collect data with the geophone, with the geode, data will be collected all the time at a very high frequency for 24 channels, and so we do not want to save data we don't need, right? So we want, this is reading data and then it erases it, doesn't save them unless we tell it to do so. How do we tell it to do so? One of the ways by which we can tell, David, I got this.
Oh, okay.
One of the ways by which we can tell it, we can use a trigger. This is basically what we call a hammer switch. It's basically a trigger. It's an that you orient on the hammer, and it feels the vibrations. And so when you hit the plate and it bounces back, it triggers that there was a bounce back, and it sends a signal to the geode to collect the data for whatever period we told it. And so, for example, for 1 second or 2 seconds, right? So what we want to do is put this trigger on the plate, on the. Now we're going to be hitting that way, and so it's really important that we put this like that and parallel to the impact source, which is going to be here. Not this way, not this way, not this way, right? And so like here. And so maybe we can do that. We want it to be tight so that actually it feels it's like a unit, a rigid thing. Because if it's loose, it may not trigger.
This is a very delicate piece, and we only have one. So we want to treat this with care and properly.
The biggest thing is that you want your cable not to ever be jumped by the hammer. So it's best to, as you do this, you don't want this to be pulled. So it's best after you've done this to really tape this a little bit more, so that the cable is never pulled from where it was. And then this one is also helping to take it far enough. Something like that.
This piece is also important because when you hold up here, you could accidentally pull on the cable up here, and this actually anchors before pulling on that.
So now we'll be able to hit with this, and hopefully it will trigger. And the end of it goes to, this is the button on the side, goes here. Very similar to the previous one, I rotate only, I don't push, and goes in. So now, when we connect it, we'll be able to trigger and collect the data. However, we're not able to see the data unless we connect it to a computer. So this is the data cable that will transfer the data that has been collected by the geode to a laptop where we can see the data. And so we can do that here. There must be. Oh, do we need to use that too?
Not now. But we should
Yeah, no,
explain
this is for, yeah, we can explain. But where is the other end?
other one.
No, yeah, okay. Yeah. All right, sounds good. So this is goes in the one end, it goes here. And the other end goes here. And this end is a cable connection that goes into the laptop. All right. So this will allow us to look at the data. The last thing we need is to power this thing up. The computer has its own power, doesn't need power, so it's only data here. But we need to power up the geode. And a 12-volt battery will work like a car battery. This is not a car battery. It's a 12-volt, a car battery will be 12 volts and 10 ampere. This is 7 ampere, so it's smaller. 5 ampere will also work. In general, by being a smaller amperage, doesn't last that long, but it's lighter. And so it's better to carry 2 of those than 1 car battery for field effect.
If we have a single, like that single battery,
Yes.
then how many profile can we?
Yeah, 1 battery could potentially, it's a function of how long it's powering, right? Because you can turn it off, right? But in general, 1 battery can last us more than a day, possibly 2, depending on the management. And we always have more than 1, of course, and we're charging the other 2 when one is being used, right? And so for that, to do that here, you will see that here there is a power. It says battery, so you turn this, you take this out, and we put this here. There's only one way to put it, which is this way. All right, and then we can power it. Red to red and black to black. All right, then there's a button that you can press here, this red button, and it will blink a blue light which indicates that it's powered. All right, sounds good.
Yes, sir.
You can see
Sir,
that
one
with these
question.
different parts.
Okay, sir.
It's useful to kind of organize this part because you actually you have to sit to operate the computer. So you want to try to make a workspace. Sometimes it's good to have an extra box or the bag so that you can put the computer on something stable so it's not slipping all the time.
You want to say about the reel also?
Oh, yeah. This arrangement right now, this trigger cable actually goes to here, and so the distance the hammer goes from here is really short. And so a source right here at this end is no problem. But if you want to do another source, like in the middle, you don't want to have to move the box with it. This is an extension cable. So as you're planning, if you think you want to do more shots further down, you would actually plug this into this cable, and the other end of this cable goes into the box. Exactly. So you have more cable to work with as you move this.
All right. You had a question?
Yes, sir. Sir, the distance between the geophone and the source must be constant, or we can expand it also whenever we need.
So you want to, once you start hitting, you want to be at the same distance, but it's about 10 to 20% of the array length, and you don't want to be too close and you don't want to be too far.
Sir, once again, when we bring the source near to the geophone, what will happen?
If you bring it too close, you may
yes.
max out the geophone response and you may not have your signal. It will max out. It will not have the whole time history. It will reach maximum voltage and you will not record the time history.
Thank you, sir.
There's a survey design issue here that you're actually asking about. A 1D survey for MASW, you would put one source here at the end and just record one source point. For the refraction, you would actually do one on this end, at least one on the other end, and one in the middle. So 3 minimum. So where you want to space them depends on the type of survey you want to do. And a 2D MASW, you actually collect all the way through at maybe every other geophone spacing. But I think tomorrow it's just 1D.
Yeah,
1D.
we can do, unless we do that for the P-wave.
Yeah, the P-wave we want to cover.
So if you hit in between here, the geophone may max out and you may not have the signal in the near ones, but you have signal in the other ones that are relatively close. So you process the data that you have access to.
Okay, thank you, sir.
Any more questions? All right, we can power this in. Let's see the blue. This is blinking still? Yeah, this is blinking. Right. So we turn it on to see just the data. So if you want, you can come behind, or maybe I should come on this side myself. All right. And so, did you?
Let's try just saving some point.
All right.
Is this laptop especially designed for this?
Not
the
really.
survey?
It requires to have the software. So, I mean, it can be used for other purposes, but yeah, once you put the software there, you want to be using it for data acquisition. Because this, what we're using here is the geometrics module, right? So it's their software and all that stuff. Once you have the data, you could process it with any other technique, but of course they have the data processing.
Means the box that it is costume or customized box for the laptop?
This one?
No, this one, this.
No, no.
This all, this one.
No,
So
it's not. It's not.
it's not customized?
No. It just has to have enough connectivity and all that stuff. No, it's a regular, it's rugged so that it can survive in the field.
Okay. It's just a regular laptop
yeah,
cover
but
with
it
a
is-
protective cover.
Yeah. So we're waiting now. So now it's starting. It tries to see if it can see all the geophones. Sorry. We'll take a
Sir,
little bit
what
of
is
time.
the name of the software that we are using here?
Size module it's called. Size imager. So it's size imager. Geometrics is the whole thing. They have lots of software for data acquisition, for data processing, all that stuff. The whole thing is a geometrics setup.
The company. Geometrics.
So you guys can see now here on the left, if you can come around, maybe I can go here and you guys can see. There is on the right is the time domain signal, and you can see all the geophones to the degree that if we step down, you can actually record this. You can see the signal. None of it is saved. So these are gone, right?
Yes.
And so what we want to set up is a survey by which once we trigger, it collects data for a certain period of time, and we look at the data, right? And so the first thing that you want to do, and you can do it also by hitting with a hammer, but in general, you want to make sure you get a signal that looks
24 is here. Tabara, yes.
24 bar.
24.
See, he's walking.
Okay.
That's his
It's
footstep.
This is geophone number 24.
24.
24
not all, if one of the geophones is not hooked up, not
They were
coupled well to the
one
ground,
month.
it may actually look like it's actually not behaving as well, right? So.
Straight line.
This is a blue color. The line is blue. What does this
Oh,
mean?
nothing. It's
nothing?
Every 10.
Okay.
Yeah,
10, 20.
just to do it for graphic purposes. It has nothing else.
Okay.
All right. So what we can do now, I can show you here. So this is the software is just collecting the signals, right? Doesn't understand anything else, right? So you need to make sure that you put the right input in it, because otherwise it will be confused about what you're doing. So here you can go to geometry. So this is one survey. We can go to geometry and put geophone interval. So here it has 2 meters because that was a previous survey. If I don't change that and I collect the data and somebody processes, it will feel that it's 4 times longer than right. So all the velocities will be wrong and nobody will know, and that's why we need to be careful about it. So I put 0.5 meters. Then once I put the geometry, we'll see the array. Actually, you can see it already here. I need to put my source. So go back to geometry and I put group shot locations. And so what you see here is geophones every half meters. It also actually has a coordinates every half meters. In fact, on one end, it's 0. You can put this 0, I think. I can change that up. I can change that coordinate to 0. And if I set that coordinate to 0, it knows everything else is half a meter and will go here. It goes on the negative, it's okay. And it says here should be my last geophone should be at 11.5, which is what we have here. This would be at 11.5, right? So you can confirm that it's good to check. Now our source is another 1.5 meters away. So I can put here, if this is minus 11.5, I can put here minus 13, and it will be 1.5 meters away, right? It's good to do all these checks, be systematic, because you will make mistakes. You're getting tired and all that stuff. You don't want to be, you want to be checking your work along the way, because otherwise mistakes are happening. One geophone is not correctly connected, there wasn't correctly spacing, it wasn't there, and then you come back and the survey is bad. And it's actually worse if you don't even know about it. All right, so acquisition. Now we have the geometry in, right? I can go then, so I have the geometry in. What else do I need to do? I need to specify to the software the type of data I want to collect. I need to say that, right? So I go at acquisition, and the first option is sample interval record length. So people have done it for 1.5 seconds. It's probably enough. And so it's a total record length of 1.5 seconds. 1 second was definitely, well, it's probably enough 1 second, but anyway, we can leave it. And then sample interval. How often do I collect data? For active data, we put 0.125 milliseconds. 0.125 milliseconds. How much is that? What is the frequency of that data? 0.125 milliseconds is 1 over 0.125. It's almost 1,000 hertz, a bit less than 1,000. Right? How much? I can calculate. 0.125.
These are milliseconds.
Yeah.
This is millisecond.
0.125. 1 over 1.1. Huh?
8,000.
Is it? Or 800? 8,000. Sorry, I'm not used to this calculator. 1 over 0.125 milliseconds. That's 8, so it's 8,000. 8,000 sampling, 8,000 hertz, more than enough. Like we don't need all that much, but the file is still very manageable and we can leave it like that. Right, so very high frequency data for 1.5 seconds. All right, the last thing that we're gonna do, and I haven't described that up to now, is every time I hit with a hammer, there is a wave that's going to be propagating through the geophones all the way. That wave, there's background noise. The water, people, you guys working, other people over there, somebody's working. So what we want to is to have a good signal to noise ratio. And I'll describe that later also in the second part of the presentation we will make. And so what you can do is what we call signal stacking, which is basically add your hits one on top of the other. And so it's very important. It's not how hard you hit. You want it to be decently hard, but most important is to be repeatable, for your signal to be the same. Because what will happen is you can put like for example 5 stacks is plenty here. 5 stacks 5 times we will hit, and what the software will do is add one time history on top of the other. Not take the average, add them. Okay, it's different than the average. So you add them, and what happens is if you're repetitive in your signal will be so consistent that will be added, and the background noise, which is random, a car just passed, but next time it will not pass, it will be cancelling out. And so you improve that way your signal to noise ratio. In a big, busy areas, you may do 12 times stacking. Here we do it 5 and it's plenty. Okay, so we're gonna do 5 times 5 hits.
That means in one spool we are hammering 5 times? Continuously, yeah?
Yes.
5 repeated times.
But not
No,
by
not
mo-
that.
You hit, the computer will record, and then it will tell you ready for the next one.
All right. So we're ready now. Huh? You had a question?
Yes, you get.
So we're ready to hit. A few things about the heating. The first thing is protect the cable, right? We always try to have a backup cable, but in any case we don't want to damage it, right? But we cannot have a backup cable of this black one because it's very heavy. We never have a second one. If that gets damaged, cut, squeezed, whatever, we're done. You can have a second of those because it's small. And okay, but in general you don't want to. You want to be consistent so you don't hit. The second thing is that this is recording in this direction. So you don't want to hit like that because it's not the direction that is sensitive. You want to hit flat into the ground, flat. So that as this hits, this is recording the maximum acceleration, right? Right, so what you can do is do this. And so there is a green light there that it will actually trigger once I hit the first time. So let's see. And it will become yellow. While it's collecting the data. Now, for what we're doing now, it's not the best setup at all. That I have you guys so close, that I have my cables there. If something happens, I lose and I fall on my laptop, right? So there is no reason for being the way we have it, okay? Most of the time nothing will happen, but if it happens once, it's a problem, right? So what I'm gonna do is hit. You can see the yellow, it's saving the data, and here's the signal. So we can keep hitting, but I already can see there's something going on with this geophone. You can see the signal from that geophone to there propagating, but it is clear to me 1, 2, 3, 4, 5, 6, 7. The 7th geophone is something on it.
From here, 7.
Yes, 1, 2,
It's 24. यो 24 होइन
24.
यो 24 रातो भनेको यो
No, that. यहाँबाट सेल हुने नि त 1 2 3 4 5
That's how this works.
1 2 3 4 5 6 7 7
It may not have been good contact because the moment attached it came out.
यो जुन आयो नि
So it may have not
यो हिरो राख्नु
अब यहाँ समस्या के छ भने त यो ठिकै 18 18 रहेछ अब यहाँ 1 3 24 रहेछ हैन 7 को छ यही समस्या हो
उसले साथको छ
के यहाँ के होइन यहाँ 1 2 3 5 7 छ नि यो हेर्नु यहाँ 7 नम्बरको देखाएको छ नि तर हाम्रो जिफोन त्यो 7 हो त
त्यो होइन त्यो त यता
त्यो
24
हो
हो
एल झुकाउँछ एल
यो हेर्नु पर्यो त्यो भन्दा
यो हेर्नु पर्यो क्या
त्यही त यो हेर्नु पर्यो के हैन
अब 18 को देखाएको 7 देखाएको 18 देखाएको
Okay, let's close down the GPS and start hacking it up, okay?
नहान नगर जान्ने कोही हुने होइन अहिले जे भने गर्ने नगरेको कुरा आफूले गर्ने जान्ने छु भनेर आफूले केही गर्ने
सेन्सर सेन्सर
something like that. Let's try again.
सोर्स दियो क्या अब सोर्स दियो हैन
So that's the surface wave.
It's really important to look at the
Wave front,
signal,
that's
right?
the
So I
P
will
wave in
cancel
front.
that hit because of the first shot. So I will stop here. Acquisition of a file. Display, view survey, clear memory. So I'm erasing it because I didn't like the signal of that geophone. I'll do it again.
Step back, step back.
All right. So I'm gonna hit here now. And I don't want to see this again.
No, that's fine. That's fine.
So we fix
Fine.
it.
No, it's
All right, now have a green light, which means I can hit again.
Okay.
Can you, Irada, can you go far a bit? Thank you.
That's only still blue light.
no, that's blue line is good.
Blue line is nothing. It's
Blue line is nothing. So,
No,
Okay,
orange,
the
sir.
second thing is keep in mind as you guys walk that actually you are affecting this geophone is very close to us.
Yes.
So we should all be very stationary before I hit, okay? So nobody moves once I hit.
no, it didn't turn.
It didn't trigger?
It didn't trigger.
Let me put it.
Yes, it triggered. No.
3,
Yeah, it's
Nobody
changed.
moves?
No,
4,
yes, it changed.
5.
Yeah.
So if all goes well, at the bottom here it will save the file name and we should write that down. 1272 file. Now tomorrow we're gonna have a pad and we'll be writing things down. But in my notes, which I don't have now, maybe we can write it down. So what I always do, everybody else is working? Are they gonna pack up the also and redo it or no?
We pack everything up in the next group
Again.
unpacks. We do have your notes or
Survey number 1. Yes, this is the sheet that I use. But what I typically do anyway is a schematic like that, where I put all the geophones. I write that this was a 0.5 meter spacing. I put that my total length is 11.5 meters. I put also here my coordinates that is 0, 0. This is 11.5. And then this one with my sledgehammer is 13. And so then I know that this is 1.5 meters, right? And this is my sledgehammer. And then I say 5 stacks, data collected for 1.5 seconds duration at 0.125 milliseconds, which is super fast. And the file name is 1272.
272.
File 1272.dat. Now I see this signal and I like it and it looks good. But before I didn't like it, right? If I had collected it, I would save and say, oh, 1272, I did it, but one geophone 7 doesn't work, and so I repeat. And then I will say the next one, I fix this and this. That way I have a pure log.
Yes.
Now, because I saw it immediately and I didn't do a survey, okay, maybe I don't need to write it. But it's very important to write even for files that you saved why you're not using them. Because somebody else will pick up these file names and say, okay, I'll use 1271, looks the same.
Yeah.
It's not the same, there's something else. And my notes should say what it is about. All right? So that's the type of logging that I write there. All right?
It's useful to write the time. Okay.
Yes, absolutely, the time, for sure. Yeah, well, every time typically I write the time I start and the time that I picked up the survey. All right?
3:35.
And okay. Any questions? We look. So